reading quiz grades. Well, one student came to me and said that, you know, they and other students were under the impression that reading quizzes were just based on if you attempt it. And no, it's not just based on if you attempt it. But I am trying to make it as much of a learning experience as I can. So the way the grade is you get 50% for doing it on time. So that is half of the grade there is for attempting it on time. And then the other 50% of your grade on the reading quiz is your grade at the test time. So the reason I have that is to give you some incentive. Even if you didn't get it done on time, you can go back and get some points by still doing it. So that's 50% of your grade, what you got right, the score at test time. Another thing here, OneNote. How many people have tried to connect to the class on OneNote and are still having difficulties? Okay, so that's 5 people that I count. How many of those people is it that you don't remember your password for your Union College OneNote account?
It's the same password they use. The same password.
No, it's not. It's not tied to that at all.
It's not, but I use the same password when I signed up for it.
So if you have that problem, it's supposed to be Michael Calkins that can help you, but I haven't talked to him. I'll send an email. Well, I sent an email and didn't get a response.
Yeah.
So I will try contacting him again, because I think the OneNote is actually very useful for us. And so I want people to be able to use that and to have success. Let's see, there were a couple other things I wanted to try to remember here in the beginning. I'm going to do I'm going to do a homework problem during the lecture here. Something that I was just working over with Ashley. When we talk about coordinate systems, what are the traditional labels we give to the 2 directions if we have a 2-dimensional problem? X and Y. So traditionally we use X and Y. Now, at least some of you, I think this is only the people in 251, but it might be everybody. You have a problem that says you have the initial velocity is equal to V0 X I hat, and then you have V1 equals V1 X I hat plus V1 Y J hat. I hat and J hat is a standard, not the standard, a standard way of indicating X and Y directions. And so the X direction, I'll make a little table here. X direction, Y direction, Z direction. These are sometimes written as X hat, Y hat, and I know I didn't give myself enough space, Z hat. Those little hats, and I know if we were French, we wouldn't say hat. We'd say like carré, right? But we're not French, so we say hat. The hat means that it has a magnitude of 1 and a direction as specified. So it's kind of like the opposite of a scalar. A scalar only has magnitude and no direction, whereas these hats have direction with a magnitude of 1. Oh, this is great. I have Michaela and Michaela at the same table. That at least makes life a little easier. I look over there. Another way that those are specified is I hat, J hat, and K hat. Those are sequential letters in the alphabet, just like X, Y, and Z. So I hat means in the X direction, J hat means in the Y direction, K hat means in the Z direction. And then there's even some other more esoteric ones that we won't use. So the standards, when you see that I hat, it's, jargon type thing that you have to have that connection. Oh, I hat means in the X direction. X hat means in the X direction. So they're equivalent, right? Because if you don't know what those mean, that really complicates your life. Any questions about that? Okay, then let's get going. Graphical addition. Addition. I'm addicted to graphics. Graphical addition, we talked about it last class period, and I said, the textbook uses the term head to tail. I learned tip to tail. And so when you add two vectors, so this shows F1 plus F2. When you add those vectors, you draw F1 vector first. So you have the tail is where you start, the tip is where it ends. And then at the end of that tip, you put the F2 vector. Now, when you're doing this, you do have to use a ruler or protractor with a scale if you're going to do it correctly. And so I'm going to do problem 4, which is an example that you could solve either way, and I'll do it both ways so that we can see some example of that. Now, one thing that's important to note is F1 plus F2 is exactly the same as F2 plus F1. If I were to do F2 plus F1, I would first take this F2, and then I would have to add the F1 at the end. So I would have the F1s like that. And if I take going from beginning of F2 to the end of got to use a different color. Don't be ridiculous, Richard. So there's going from F2 to the end of F1. So this here should be F2 plus F1. And if I do the other way, F1 plus F2 is that. So they give you the same resultant. So it doesn't matter what order you put the vectors when you add them. When you're doing your graphical addition, you just have to put them. Now notice the picture that has the big red Ghostbusters sign or whatever. You do not add them as, actually this one here is just showing the resultant done wrong. I thought this was showing them added wrong. And well, yeah. This here is showing the resultant wrong. What's wrong with this resultant? It's going the wrong way. You don't continue back to the origin. You go from the starting to the ending. So this is wrong because that's going the wrong way. Other things that you could do wrong, the most likely thing that for people to do wrong is to go like this. That's not what F1 was like. To put F1 like this, and then to put F2 like that. What's wrong? Oh, besides my handwriting, which is in rare form today, what's wrong with that? I have tip to tip instead of tip to tail. And so that is not adding. That is most definitely incorrect. And so don't do that. I show you what not to do so you'll know not to do it. Now, one last thing here. What if you're subtracting? What if I want F1 minus F2? I will tell you the answer rather than have you come up with it. But the answer is really simple. F1 minus F2 is clearly equal to F1 plus a negative F2. We know how to add vectors. What difference does it make if you put a minus sign with the vector? You just swap the direction. You flip the direction. So to subtract F2 from F1, I just add F1 and minus F2. So I take my F2 vector. The F2 vector was going down and to the right. And I say my minus F2 vector. There's the minus F2 vector. And of course, my F1 vector was like this. And so if I subtract them, I'm just going to put there's my F1 vector. Here's my minus F2 vector. And so then my resultant is like that. So that's how we subtract. It's, when you think about it, it's really elementary. But you have to at least have the idea, or else you can just be off there like, I don't know what to do. I've never subtracted vectors before. So that's the end of my explanation of graphical addition. I will show an example, a homework problem. You'll have different numbers, so you'll have to use the method, but not the same results. I will show you how to do it both graphically and analytically so we can compare the two. So now let's get into analytical. The analytical method is where you actually get numbers and add numbers. And it all starts with our trigonometry, which is why we spent time talking about what sine is and what cosine is, and learning other things like, well, if you have a right triangle, one angle is 90 degrees. Whether it's a right triangle or not, you always have the sum of the interior angles. What's an interior angle? It's an angle on the inside. So the sum of the interior angles is always equal to 180 degrees. You use that fairly regularly. I'll show you the law of sines and cosines in just a moment, because if it's not a right triangle, and even sometimes when it is, you'll find yourself using those. And what we do is we break a vector into its components. So components, what does the word component mean to people outside of physics? Parts, yes. I use plural, so that's why I said parts for. So components are the parts. So a vector is made up of parts. What are those parts? The part parallel to the x direction and the part parallel to the y direction. So if I have some random vector, let's say I have a vector that goes like this, and it has a length of, let's say, 5, and let's say that I know this angle is 30 degrees. Why do I choose 30 degrees? Because I don't know about you guys, but when I was a sophomore in high school, I had to memorize the trigonometric functions results for 0, 30, 45, 60, and 90 degrees. So I choose the ones I had to memorize when I was in high school. So it has a magnitude of 5 for its length. It has an angle of 30 degrees there. I always need to identify what my coordinate directions are. So there's my x and my y. So I want to break this vector with a magnitude of 5 and that angle of 30 degrees. If I specify the vector right now, let's call this vector A. How would I specify this vector? How would I write it down? Cole, do you have?
You would break it down into its x and y components.
We are going to do that, but before I do that, I can still write it down as a vector. Because we are going to do that. That's not an incorrect answer. It's a correct answer. Just with this information. Looks like I didn't make this clear on Wednesday. We put down the magnitude and then the angle, and then we need to have a reference for what direction the angle is and where it's from. So my magnitude here is 5, whatever my units are, so I'll put units so that we have units, so it's some kind of legal magnitude, and then I'll use the at sign to say at its direction, and its angle there was 30 degrees, but I cannot stop there. 30 degrees measured what direction from a reference point? So what's my reference point for that 30 degrees? Okay, well, based on my x and y definitions, y. So it's something of y because it's measured from the y-axis. It's Okay, and this one is a hard and true fact in physics. Counterclockwise is a positive angle. So if I put a positive angle, it means measured counterclockwise. Well, conveniently enough, this is measured counterclockwise. Right, it's measured that way from my dashed line. So it's going to be something of y, and I put a hat over the y to say from the y direction. What axis am I moving toward if I'm going counterclockwise here? Toward the minus x. So I'm going to put minus x hat of y. That completely specifies my vector. It has the magnitude, it has the angle, and it tells you where the angle is measured from and to. Yes, everybody. Because since the plus x-axis is over here to the right, and this is going toward then the minus x direction. So I have it specified there in magnitude and angle. But now we want to break into components, what Cole had said. So to break this into components, what I'm saying is this has two pieces. One piece that's parallel to the x-axis and one piece that's parallel to the y-axis. Now you notice I drew dashed lines, one starting at the tail parallel to one axis, one starting at the tip parallel to the other. I happen to choose going horizontal from the tail and vertical from the tip. You could have chosen just the opposite. It'll work out the same. And in fact, it takes a little less work if you do it here because the angle is specified inside of this triangle. So let's look at this, the components. The components is going to be two vectors, one parallel to the x-axis, one parallel to the y-axis, that when I add them together, it gives me my resultant vector. And so I can look at this picture and say, well, clearly, I have a bad habit of double-clicking. Clearly, I have to add this vector component and this vector component, and then those will add to my total black colored here vector. So I just need to find what these are. And so now I'm going to use the trigonometric functions. So I know one side of the triangle. Which side of the triangle is it that I know? Okay, the hypotenuse. The triangle is the one made up of the red, blue, and black, right? Because it has the two components in the vector I'm trying to resolve into components. And so the longest of those is the black. Hypotenuse is the longest in the right triangle. It's also the side opposite to the right angle. So I know the hypotenuse. So I can come over here and say, okay, I know these two sides. If I want to find the x-coordinate, is that the opposite or adjacent side of my triangle? The x component is going to be the one that's parallel to the x-axis. And so that's actually the opposite side. It's the opposite side. So then I look at my trigonometric functions and I say, which trigonometric function relates opposite and hypotenuse? We can all answer which one relates opposite and hypotenuse. Sine. So I can look at this and I can say sine of my angle is equal to the opposite side, which is my x component, divided by the hypotenuse, which was 5 units, whatever those are. So, and this is the easiest math you ever see in physics. To get the x component by itself, I'm going to have to multiply both sides by 5 units. So that I will have canceling here. And I end up with 5 times sine of 30 degrees. Sine of 30 degrees is 1/2. 5 times 1/2 is 2.5. So it's 2.5 units. but I'm not done. I still have to use my brain for one more step on the x component. Is that in the plus x direction or the minus x direction? It's negative. It's going the minus x direction. So my x component is minus 2.5 units because of the direction. So it was my brain that told me the minus sign. The minus sign didn't come from the calculator in any way, shape, or form. It came from thinking. So now I'm left with the vertical part. The red line. Is the red line adjacent or opposite? It's adjacent. So now I'm going to look here and say cosine theta has the adjacent. And so I'm going to have cosine of 30 degrees is equal to my y component divided by 5 units. Again, multiply by 5 units across. I have the y component Somebody's already got the answer for us. It's what?
4.33.
So 4.33 units. Is that positive or negative? How can I tell? Is it parallel or anti-parallel to my y direction? My y direction has up as positive. Did I go up or did I go down? I went up. Anti-parallel means the opposite direction. So anti-parallel would have been down. Since I went up, it was positive. And so now I can write my A vector as minus 2.5 units I hat plus 4.33 units j hat. So that's two different equivalent, both correct, ways of writing a vector. And you need to be able to go back and forth between them. We just went from the vector with a magnitude and an angle to the vector with an x component and a y component. How would we reverse it? How would we go from the components to the magnitude and the angle? Go ahead.
Add up the components.
Mathematically.
Or, it's the square root of x squared plus y.
Yeah. The Pythagorean theorem. The x component squared plus the y component squared is equal to the resultant squared. So we use the Pythagorean theorem if we want to get the magnitude from the two components. And how would we get the angle?
Using whatever trigonometric function you want.
Using whatever trigonometric function you want. And we went through this last class period. I know once I use the Pythagorean theorem, I know all three sides of the triangle. So I could use any one of these to find what the angle is. You have to use the inverse function. So I would have a sine theta is equal to BO, wrong, theta is equal to a sine of B over C using the ABC definitions here, or a cosine of A over C, or a tangent of B over A. You could use any one of those. I recommend using the one that has the least math work you did to get to the variables, just so you have less round-off error. Probably students aren't nearly as concerned about round-off error as I am as a teacher. Any one of those will work to get back to the angle. And then once you have the angle, remember, you have to specify what direction you're measuring from where. And hopefully, when we actually do an example, this will make great sense to you. So a couple clicker questions, I think, right here, and then we'll be about ready to do our example. So for a two-dimensional coordinate system, what spatial relationship must x and y directions have? I talked about this carefully on Wednesday. Little mentioned it today. Boss has answered. You saw my reply to your email, right? And yes, it's channel 33, or if you're using your phone, it's and you can't be like Corso and say, well, you just said it 5 minutes ago. Okay, waiting on Trace, Corso, James, Abigail, Irving, and Leslie. Corso's in.
Mine's not picking up or receiving.
Yeah, I'm not.
Not picking up.
I'm watching on 33 as well.
Yeah.
Yeah, try what Irving's doing. See if moving makes a difference, because that's a little distressing. Yeah, there you go. Irving and Trace I don't have. There's Trace. That's a little disturbing, isn't it? Okay. Are you working on Abigail or what?
I am, it's not letting me sign in.
Not letting you sign in.
I have the answer written down on it. It's not letting me sign in.
Okay. I'll go forward and hopefully you'll get signed in before we get to the next one. So, our answers here. We had, this is going to be tough for Brandon. What'd you answer, Brandon? Man, what was your reasoning?
Well, you look at a flat graph, your x and y are perpendicular to each other.
Okay. They have to be perpendicular because otherwise you wouldn't have a unique description, is the technical answer, but that is a practical answer that perfectly works for me. So when we do an analytical solution, here's some steps I wrote down. Number one, select a convenient set of mutually perpendicular coordinate directions and add them to your figure. Usually, we do horizontal and vertical. Why? Because usually we're doing something with gravity, and since gravity is vertical, we want one of our directions to be parallel to gravity. Sometimes we will use different orientations. They just have to be perpendicular. Next, break each vector into its component using sine and cosine. And now comes the part that I remember back in high school, my teacher was saying, you can't add apples and oranges. You know, students made the jokes, oh, what about a fruit salad? You have to add only like components. So when you add two vectors, you add the x components separately. You add the y components separately to get your resultant. Then you use the Pythagorean theorem to find the magnitude and use tangent, or arctangent would be as appropriate, to find the resultant. So here is a picture showing the mechanics of adding two vectors. So you have the red vector A, you break it into its two components. So you have AX in the horizontal, AY in the vertical. You find those by taking this angle and the adjacent side. In this case, the adjacent side is the X direction. Did you notice in my example, the adjacent side was the Y direction? Here, the adjacent side is the X direction. You have to pay attention. A very large percentage of the time, we measure our angles from the x-axis. And so sometimes students simply say, for the x component, it's going to be cosine. But you have to check where your axis is and where you're measuring your angle from. You don't just take a blanket rule, because the blanket rule doesn't always come out right. Then you do the same thing with the next vector. So you find the B components based on your angle there. And then you add the A's, or the X components. So here's AX plus BX to find the resultant. And you add your Y components AY plus BY to find your total in the Y direction. It looks simple enough, right? No? To me, it looks simple enough because I'm the teacher, probably. Okay, so let's go to the homework. And this is homework 5, problem 4. That's the one that's due this afternoon. Remember, what time is it going to be due? Yeah, 7:50. It says that right here in case I didn't remember. So we have a person taking a stroll. It's a short stroll. And the numbers that I had are different than what you'll have. Goes 75 meters at an angle of 21 degrees south of east. Then 130 meters at an angle of 19 degrees north of east. And finally, 75 meters at an angle of 67.5 degrees north of west. Notice that each of these directions is measured with a different specification for the angle. So the first thing I did is I wrote them down with the specifications given. So A is 75 meters at 21 degrees south of east. I drew myself my coordinate system. So here's my coordinate system, north, south, east, west, and then I put an X and Y. So X is positive X is east, and positive Y is north. And then I'm going to put these in angles measured from the X-axis toward the Y-axis. So I'm going to put them all in angles that start here and go like that. So south of east means you're starting east and going south from there. Well, I should turn around like this. Starting east and going south of there. It worked for me, but you were, of course, on the other side. So in terms of X and Y, which Y is east is the X-axis. If you go south from the X-axis, are you going toward plus Y or minus Y? Minus. So that's going to be minus 21 degrees Y of X. B, 130 meters at 19 degrees north of east. So I start at east because that's where the of is, and then it goes north. So it's going to be just positive 19 degrees. And then the last one, 67.5 degrees north of west. What axis is that starting at? The negative X. Well, I want to put it in from the X-axis just because I want to. I want to get it in something standard. So to get it in my standard, if it's 67.5 degrees, I'll go this way, so I'm going to be the same way you. 67.5 degrees north of west, then how far is it from east? What's the angle between east and west? 180 degrees. How many people are like me and just laugh when somebody says they are going to turn things around 360 degrees? I laugh because, I'm a nerd, like we established. What were we going to say, Corsa? No, okay. So it's 180 degrees. So 180 minus 67.5 is, what'd you say? I would probably say smaller than that. 112.5 degrees Y of X. So I put them all measured from the X-axis. So I just did that so I would have an easy way of looking at the angles. You may never use that, but I want to do that. Now we have two methods of doing this, graphical or analytical. If I'm going to do it graphical, I need to get a ruler and set a scale. And so I have a picture that's I know some of you are following along in OneNote, probably scrolled up. Hey, look, he's got the picture. I used a scale that on my screen here, which isn't going to be on that screen, was 1 centimeter is 25 meters. And then I plotted these out, tip to tail, carefully measuring the angles. Okay, I cheated. I had Excel plotted out. So the angles are all exactly right, which is why my answer comes shockingly close to correct. And so here we have it. So I have the vectors, and notice they're nicely color-coded. So vector A, 20 degrees down from the x-axis, B 19 degrees up from the x-axis, and C 67.5 degrees up from the minus x-axis. They're added tip to tail, one's at the end of the next. And then, and I actually did this, I put a ruler on here and drew that line and measured its length and measured its angle. And when I measured its length was 7.40 centimeters. So using my conversion factor that 1 centimeter is 25 meters, it gave me 185 meters. And with my protractor, I measured 26.5 degrees north of east. And so this is my answers for adding the vectors, doing it graphically. So like I said, you're going to have to do that on the exam. Now the exam, I'm only going to give you probably 2 vectors. Just, why should life be hard? Make it the minimum amount that's doing addition. But you will have to show this kind of process. And I'm going to be grading on you showing the process, right? You already know the answer. It's going to be given to you, right? It's the process that I'm looking for. Okay, so do I have any questions about how I did that? We're all clear? Okay, then doing it analytically. Doing it analytically, I'm going to break my vectors into the components. And so a vector, that's, had distance A, so I'm calling it a vector. It was given up here, and actually, if life is good, oh, you know what? I don't know that this has a duplicate function. Copying is all fine and good, but I want to duplicate it. I'll have to look into that. Haven't used this enough. Well, let's not. Well, sure, I can drag it. I can just get rid of it here and be happy. If I had a keyboard, I probably could have just, oops, great. Almost made it. There we go. Okay. Apparently, I took another piece. Use the T. Oh, well. We're close. So here I have them written out. Now I need to break them into components. So let's just draw this A vector by itself. So drawing the A vector by itself, I'm going to have, here's my x-axis. Actually, I was thinking I can do this smartly. That one. So I have an angle that's something like this. Components are like that. Seeing that nice? My handwriting got a lot better. So I have this angle here is 21 degrees. This magnitude is 75 meters. And it started here and ended there. So that means that my components go like that, and then like, not that color, that color. And then like that. So now let's find the x component and the y component. So AX, is that the adjacent side or the opposite side? And I'm going to ask you how you know after people answer. Is that adjacent or opposite side? Adjacent. How did you know?
Because it's area is measuring horizontally.
It's not just because it's horizontally. It's because it's a side that makes part of my 21 degree angle. And it's not the hypotenuse. The angle I'm looking at is always between the hypotenuse and the side that we label adjacent. And so since that 21 degree angle is touching the x component, that's what makes it adjacent. Because in my earlier example, the adjacent side was the vertical. So this here is my adjacent side, and that's my AX component. And so using trigonometry, I know the hypotenuse, the trigonometric function that relates adjacent and hypotenuse is cosine. And so AX is going to be the hypotenuse, 75 meters, times cosine of 21 degrees. And I actually have the numbers all calculated for me here, so we don't have any problems. So that's a 70.02 meters. AY, the AY here is, of course, is that adjacent or opposite? Opposite, because it's not making either part of the angle. It's opposite to it. And so opposite over hypotenuse is sine, hence opposite is equal to hypotenuse times sine. So 75 meters sine of 21 degrees equals 26.88. Now that's the magnitudes of AX and AY. When I put my A vector, I have to have the directions. So my A vector, is the AX positive? Is it parallel to my x-axis or negative, anti-parallel to the x-axis? It's positive because remember, here's my directions, X and Y. So it's the same direction that X was pointing. So that's going to be positive 70.02 meters X hat. What about the Y direction? Is that positive or negative? Negative, because it's going down opposite to my Y definition, minus 26.88 meters Y hat. So there's my A vector. My B vector, the B vector was so I'm going to draw that, and it has the two legs like meh and meh. Once again, perfect triangle. So this side is 130 meters. This is 19 degrees. So BX, is BX opposite or adjacent? Adjacent. So that means it's going to be the hypotenuse times cosine of my angle. And BY, that's the opposite side. So that's going to be sine the directions of the arrows is important. Is my X going to be a positive or negative component? Positive. Is my Y going to be positive or negative? Okay. So that means my B vector is equal to 122.92 meters X hat plus 42.32 meters Y hat. And finally, I have my third vector, which is 75 meters at 67.5 degrees north of west. So it's something like that. And we have the angle at the bottom here, so I'm going to draw it like this. 67.5. So here's my CY and my CX. So CX is equal to, is that adjacent or opposite? It's adjacent again. You see how it's most of the time we measure as adjacent. Is the X component positive or negative? Is that parallel to the x-axis or anti-parallel? It's anti-parallel, so it's negative. What about the CY? Positive. So now we have our C vector is equal to minus 28.70 meters X hat plus 69.29 meters y hat. We're adding these, and so we add the x's separately from the y. So I add the x column, and when I add that x column all together, I get 164.23 meters. Then I add the y column, and adding the y column, it gives me 84.74 meters. So now I have my resultant that goes 164.23, 84.74. Close sesame. Okay, I didn't do a good enough job on that one for it to do it automatically. Come on. I can't even erase that now. The pen stopped working. We should all be very proud of Microsoft for making such a reliable product. Oh. Okay, we're not going to worry about getting it all beautiful. It's nice enough. So, how do I find R? Pythagorean theorem. And you put that in your calculator and get it all done, and it comes to 184.81 meters. That's really close to my 185 I got with my measurements. I was really pleased with that. For the angle, tangent of theta is 84.74 meters over 164.23 meters. Therefore, theta is equal to arctangent. Notice I'm going to let my units cancel here. Equals 26.5, or no, not 26.5, that's what I had measured. 27.3 degrees. And then I have to look at my direction, and I can write it. It was measured north from east. So my resultant vector is 184.81 meters at 27.3 degrees north of east. So there I've added the vectors two different ways. One was graphically, one was analytically. Which do you prefer? Analytically, do you want to say graphical? Okay, well, let us go back to the lecture and answer one last PowerPoint clicker question. I was going to do the law of cosines and sines. I have a homework assignment scheduled, but I will have to change things because the homework assignment was going to be on all of the lecture that follows this clicker question, which clearly won't be happening today.
So there are three of them on.
Okay, while people are putting their answers, remember the supplemental homework problems are just that. They're supplemental. They are not homework problems you have to do. I forgot to put in two of them, and so I put them in yesterday, which means that they have the wrong date on them. Since they're not graded, this is not affecting your grade. I put them there so you still have the ability to go through and review those questions. So I still have those questions to go through and consider for putting on the test. So remember, the supplemental homework is not required. That's for your learning. The regular homework, the one on Expert TA, that's the required homework. And there is homework due tonight. I remembered the one more thing that I wanted to mention at the beginning of class. We still have Irving and Brittany that haven't answered. The one thing is tutorials that I have done for you to learn from. Irving, you may need to walk forward again. I don't know. Keep walking. I'll tell you when you get there. Okay, now you're in there. So we had 20 that said the preferred is is analytical for all of the reasons. 10 said just because it's more precise. If you go to the well, let's start with Moodle. Oh, let's log in. If you go to the YouTube channel for the class, oh goodness. YouTube channel. This is the playlist that comes up. And obviously I haven't made a link. I don't want to watch these, but if we go back in the channel, there is, I am so non-conversant with YouTube. This is my channel, it's going to be different for me. How do you get back to see the entire channel? Is that, yeah, that.
Click on your UC PHYS right there next to the subscribe.
Click on,
There's right next to the subscribe button that says UC PHYS.
okay. Okay, so if you come here, there are a couple playlists, and one of the playlists is, show me the playlist. One of the playlists is tutorials, homework problem, here's tutorials. And so there's 10 in there, and of course it's going to start playing. But you have tutorials here that I made on adding vectors, solving problems with Newton's second law, Gauss's law. It has a couple things. So I have some tutorials there, and I will, adding vectors is the reason I'm pointing out, because that's what we studied. Okay, have a great week.